So here is a very interesting line drawing. It's a line with two parts. And notice it has a corner. And here's the next one. Voila, it moved. Back, forth, back, forth. I can do this all day. Okay? And you can see it moving. Okay? Great. Let me put an aperture over that. So here is a great big green aperture. All right? And now I'm going to move that line thing the same way. And now it goes like this. Whoa. Now it's moving up. Or at least it feels like it's moving up. Is it moving up? No. In fact, here I've made it transparent. Okay? So now this is the same motion, right? In fact, if you look at the corner, you can tell this thing is moving over and down a little bit. But if you were to look just inside the circle, it looks like it's moving up, not down and over. That's the aperture problem. Okay? You can only tell the motion locally in the direction perpendicular to the edge. There are some other effects of getting sort of strong gradient flow. So this is a single pattern. And then I'm going to use PowerPoint to just put this in motion using animation. So there's no video going on here. This thing is just moving back and forth. And hopefully, as you see this move, every time it bumps, you're going to see the inside move relative to the surround. It's not actually moving. That's in your head. And that's because of various noise and various ways of computing the gradient. More details, and it's not just the aperture problem, but it's showing the sensitivity in your mind, in your head, of the gradient. The aperture problem also is sometimes used to explain the barber pole illusion, right? So it's spinning around, but you see stripes going up. And in fact, in the you shouldn't believe everything you see on the web universe, some people will say that the aperture problem explains the barber pole illusion. But actually, that's not really true. It has to do with it. It doesn't explain it. Because if you think about it, the gradients here are not quite vertical, right? They are off a little bit. And so you can get a flow that's like that. And you have to do some integration to decide that the whole thing is moving up. And actually, Ellen Hildreth, a very long time ago, in her PhD thesis, looked at how you use the normal flow and you can integrate it in order to make you might see the pole move up. But it is the case that there are places out there that will tell you that this is because of the vectors.